Alright, this is the start of your second term chemistry 10th class. Alright, and we'll start with the topic that is production and uses of ammonia. It is more of a practical knowledge or the practical application of the subject, and how is ammonia produced in industry, what are the uses of ammonia. We'll focus more on the fertilizers and on the agricultural uses of ammonia gas. Alright, ammonia is widely used in several industries. Major ones are fertilizer industry, explosive industry, and the cleansers. Right, before Fritz Haber introduced an efficient method to produce ammonia in the large quantity. Before him, there was no efficient method, and ammonia it wasn't easy, or it wasn't possible to produce ammonia in large quantity. Why is that so? We'll study it when we'll see the Haber process. And to know the Haber process, before we understand the basics of and conditions of Haber process, we need to know a little about reversible reactions. What are reversible reactions and how do they differ from irreversible reactions? Irreversible reactions, most reactions are irreversible. And what are irreversible reactions? It is, for example, you light a matchstick, you burn a matchstick, and it is an irreversible change. You cannot undo it. Once the matchstick is lit, it cannot be changed back into its original condition, into its previous condition. So this is an irreversible change. All right, for example, burning a matchstick. That matchstick, this reaction cannot be undone. Whereas on the other hand, if you freeze water, if you have water in the liquid state, if you freeze it, it becomes ice. This is a reversible change. You can undo it. You can convert the ice back into its liquid state. Now this is a reversible reaction. Most reactions are irreversible, or by the way, this water into ice, this is a physical change. It is not a chemical change, but after all, it is a reversible change. Most reactions in lab are irreversible reactions. For example, if you add magnesium ribbon into HCl, it becomes magnesium chloride and hydrogen gas is given off. Now, if you react this hydrogen back with magnesium chloride, you will not be able to achieve this HCl and magnesium, because this is not a reversible reaction. This reaction is irreversible. Similarly, if you react sodium hydroxide with sulfuric acid, you will get sodium sulfate and water. Again, this is also an irreversible reaction. This cannot be reversed. Alright, they proceed, these irreversible reactions, they proceed in forward direction only, or in the right direction only. Alright, these reactants can only form these products. These reactants can form these products only. These products cannot be converted back to the reactants. So these are irreversible reactions. Now, what are reversible reactions? Reversible reactions are those reactions that can go in both ways, that is, in forward and the backward direction. And this is the symbol of reversible reaction. We use this symbol instead of this forward direction symbol only. We use the arrows on the both side, which means that this reaction can go in this direction as well, and also in this direction as well. This reaction can proceed in both forward and backward direction. That is what it means. Alright, now this is an example of a reversible reaction. That is, we have ammonium chloride, we have an ammonium salt. If we heat this ammonium chloride, we'll obtain ammonia gas and HCl gas. Now, if we react these ammonia gas and HCl gas with each other, they can also be converted back into ammonium chloride. Alright, now this means that it is a reversible reaction. This can proceed both in forward direction and in backward direction. Alright, and the forward direction is the reaction towards the right side. Reaction proceeds towards the right side. For example, this reaction, this is the forward reaction. The ammonium chloride, when being heated, it converts into ammonia gas and HCl gas. And the backward reaction is the reaction that goes towards the left hand side. For example, this ammonia gas plus HCl gas, they convert back into ammonium chloride. This ammonium gas and HCl gas, they are being converted back into ammonium chloride. All right, they'll form a white solid, which is a solid of ammonium chloride. Now this is the backward direction because it proceeds towards the left side. All right, this is a convention that we write the products and reactants on the products on the left side. My bad. This products on the right side and the reactants on the left side. All right, so the reactants for the forward direction are ammonium chloride, and the products for the forward direction are ammonia and HCl, whereas the reactants for the backward reaction are the products of the forward reaction. All right, ammonia and HCl were the products in the forward reaction, and now they become the reactants and the backward reaction. All right, because it proceeds to the left hand side. Now these the reactants, they'll form ammonium chloride. Now this ammonium chloride was the reactant in the forward direction. Now this is the product in the backward direction. All right, this is how reversible reactions work. Another example of this reversible reaction is photosynthesis and respiration. When glucose, it reacts with oxygen, it forms carbon dioxide and water. All right, now when these carbon dioxide and water react with each other, they again form glucose and oxygen gas. Now this reaction towards the right or in the forward direction, it is the reaction of respiration. Glucose burns to form carbon dioxide and water. This is the equation for respiration, whereas in photosynthesis, carbon dioxide and water react together to form glucose and they release oxygen gas. Alright, so this equation, this works in both ways, in forward direction and in backward direction. Such reactions are reversible reactions. Alright, I hope it made sense. That's it for now. I'll see you in the next video.